Bismillahirrahmanirrahim. Work power energy number 3C first. So in 3C, I can see that there is a figure. Let us draw the figure on the board first. This is the ground, and an object is there at point A, which has a mass of 5 kg. The writings on the board are clear. Small Fatima,
Yes, sir.
is it clearer now?
Yes.
Okay. So n is equal to 5 kg, and the height of this point is given as 60 meters. There is a point B here and point C on the ground. It is written AB is equal to 1/4 of AC. Okay, good. If the time to lift the body at position A from the ground is 2 minutes, what is the power used? Okay, so we know that power comma P is equal to work by time. Work done. Now what work I have done? The body is dropped from position. If the time to lift the body at position A. Okay, the body was previously at ground on the ground. I lifted it at point A. I definitely did some work, and that work is equal to the amount of potential energy that is stored in the body, right? Must remember, work is equal to whenever the transferred energy is potential energy, we can say that work is equal to the potential energy. Potential energy we can calculate through mgh, right? So we can replace W by mgh here. Always remember, whenever we will lift somebody from the ground to a certain height, we will always calculate the work done by mgh, that is equal to potential energy. Now, whenever a body is at rest and we did some work and made it come into motion, then what will happen? We gave it a kinetic energy, right? That time, the work done by us will be equal to the kinetic energy of the body. Remember, okay? Energy is equal to work done. Okay, so mass of the body that is given as 5 and G is 9.8, and height at what I took it up 60 meters divided by time. What is the time taken? 2 minutes. 2 minutes, I have to definitely convert it into seconds, so 2 into 60. Okay, so 60, 60, they will be cancelling together. 2, it will become 4.9. So it will be 24. Hmm? Something like 24.4. I don't know. Can you calculate and see? Oh, 24.5. I can. 24.5 watt. The unit of power is watt. Okay, understood? Fatima, what was the confusion here?
Sir, it was MGHT, that thing. And I didn't understand the question properly.
আচ্ছা ঠিক আছে, একটা বডিকে লিফট করতে যতটুকু কাজ করছো এটা যদি ক্যালকুলেট করতে বলে, ক্যালকুলেট দ্য পোটেনশিয়াল এনার্জি অফ দ্য বডি, বিকজ যতটুকু কাজ করবা ততটুকু এনার্জি পোটেনশিয়াল এনার্জি হিসেবে বডিতে জমা হবে। এটা সবসময় মনে রাখবা, তাইলে হয়ে যাবে ইনশাআল্লাহ। ওকে, নাও 4C. Okay, a toy car of mass 250 gram is generated by an engine of 5 joule energy. Acha. At first trail, it continues with 4 meter per second uniform velocity, and in the second trail, it starts from rest with uniform acceleration 1 meter per second. This current travels 8 meter distance. Okay, determine the required time to travel the distance in the second trail mentioned in the above step. Acha, time we have to find out. Okay, let us see. This is a question related to motion actually. C number question. Motion, force, and work power energy, they all are kindly interrelated, okay? If you can understand these three chapters very well, then inshallah at least two questions you will be able to answer in the exam very easily. Because motion, force, and work or energy, two creative comes from these three chapters. Okay, now for C. Let us see what are the informations given. For the second rail, determine the required time. Okay, so we have to calculate the time. Okay. To travel the distance in the second rail, in the second term, it starts from rest. If you see the question, it is said that in the second rail, it starts from rest. Okay. With uniform acceleration, that is a 1 meter per second square. Okay. And travels 8-meter distance. S is equal to 8 meter. So if I take a look at this, only one equation comes to my mind. Okay, let us see. So V equal to U plus KT, S equal to U plus V divided by 2 into T, S equal to UT plus half AT square, and P square is equal to U square plus 2AS. Okay. Now, as I had been told to calculate time, and this equation does not include time, so this one cancelled at the very beginning, right? We will eliminate at the beginning. Then we will take a look whether we can apply the first equation or not. To apply the first equation, to find out t, we must know v, u, and a. V, it is not given, see? So this we cannot apply. In the second one also, you can see that V is needed. So V is not given, so we cannot apply this one also. Now here, S we need given U, we need given T, we have to calculate, okay, and A given T, again we need to calculate. So number 3 equation we can use. So if I use this equation, S is given, that is 8 equal to initial velocity 0. So 0 into T plus half A is 1 and T square. Okay, so 8 will be equal to T square by 2. So if we cross multiply, T square into 1 will become T square, 8 into 2 will become 16. Okay, so T will be equal to, if you do root over on both sides, it will be 4 seconds. Is it clear? It is going to be 4 seconds. Now many might ask, whenever we do root over, we put plus minus. You have seen in many places, right? You put plus minus, but here we will not put minus because time can never be negative, right? If I ask you how many time you need to do something, you will never tell me an answer like minus 5 minutes. I need minus 5 minutes. No, there is nothing like that. The counting of time starts from 0, right? Okay, 0, 1 second, 2 second, onwards we go. We do not go backward. So that is why we will not put any negative sign here. Is it clear?
Yes, sir.
Okay. So 4C done. Now we will take a look at 5C. Achha. 5C, Ronnie lifted up a plug of mass 200 gram applying 1 Newton force at a height of 10 meter, which was tied with a string with the help of a pulley. Secondly, he released an object of mass 1 kg, tying it at the other end of the string from a height of 2 meter and succeeded to lift the list of the flag at the same height. Okay. Ronnie takes 5 seconds to lift up the flag. Okay. Here C and D both. Okay, determine the power of Ronnie to lift up the flag. Power. Again, we are lifting something up and we are asked to calculate the power. Power is equal to work divided by time, and work, as we are lifting a body up, definitely work is equal to potential energy of the body. Okay. Okay. So now 5C. lifted a flag of mass 200 gram. The mass of the flag is given as 200 gram. We will convert it to kg and it will become 0.2 kg. Fine. Then by applying a force of 1 Newton, 1 Newton force, force is equal to 1 Newton. At a height of 10 meter. Okay, so we can calculate actually this one in a much easier way because the force is given. Okay, equal to 10 meter, which was tied with a string with the help of a pulley. Okay, now what we need is the time. It only takes 5-second time to lift it up. 5-second time. Okay, so how can we calculate this? Actually, the force is given, right? So we do not actually need to calculate the potential energy now. We can do it in a much easier way. That is, P is equal to W by T, right? Work done by time. Now, work done. What is the basic definition of work done? The product of force and displacement, right? So here, force and displacement both are given. So we do not need to take the help of potential energy now. Okay, we know that what energy, what amount of work I have done, the force and the height. Okay, so W is equal to F into H divided by T. So force applied is 1 Newton into the height is 10 meter. When force and displacement both are given, remember you do not need to take the help of potential energy anymore, okay? Because it is given what force you have applied, what is the displacement. So from there you can directly calculate the work done. Easier. Divided by time is 5 seconds. So here we can see that it will be 2 watt. Okay, the unit of power is watt, so it will be 2 watt. Is it clear?
Yes.
Okay. Now in D, will the second process follow the law of conservation of energy? Acha, second process. Secondly, he released an object of mass 1 kg, tying it at the other end of the string from a height of 2 meter. Acha, ঠিক আছে. Let us see. Acha. An arrangement has been drawn to, facilitate the understanding of the question. I hope you all understand or are familiar with the concept of pulley. Okay, pulley is something like this. I think my marker is getting faded. Let me change it. Okay. So the arrangement of pulley looks like this. Okay, here we will tie some load, and here we will apply some downward force so that we can lift it up. Okay, this is the concept of pulley. Okay. Exactly. Secondly, he released an object of mass 1 kg, tying it at the other end of the string. Let us say this is the mass 1 kg. I tied it at one end of the string and I released it. Released it means I let it fall. So it is no more going in the upward direction. It is going in the downward direction. Okay. Mm, from a height of 2 meters and succeeded to lift up the flag at the same height. From a height of 2 meters. This is at a 2 meter height from the ground. So as it is falling down, we have to show that it is following or maintaining the conservation law of energy. So in such case, you know that what we do, we take a point where it is now, okay, and from where it is letting it fall, That is the point. Let us say that point is A, and we will take a point on the ground. Let us say that is C. So if the total energy at point A and the total energy at point C, if they both are same, then what we can say, it has followed the conservation law of energy, right? So from here, as we are letting it fall down at point A, what is the total energy? The summation of potential energy and kinetic energy. Now the potential energy here we can easily calculate by mgh, right? And kinetic energy will be half mv square. Mass is 1 kg into g is 9.8 into h, height is 2 meters. Okay, plus as the velocity is 0, see, and from here we started, it started to fall down. That means here the initial velocity is 0, then when I let it fall, it will gain some velocity, right? So initially it will not have any motion, it will not have any velocity. So half m, the velocity is 0, so this whole part will become 0. Now 2 into 9.8, it becomes 19.6 plus 0, so 19.6. As we are calculating energy, it will be joule. Okay, this is the total energy at point A. Now let us see what will be the total energy at point C, whether it equals the total energy at point A or not. Okay, better we represent this one as EA. The total energy at point A is represented by EA. Achha, now the total energy at point C, let us represented by EC, and again we will calculate the potential energy for that point and kinetic energy for that point. And that will be mgh plus half m v square. Now mgh, m is the mass, that is 1, g is 9.8 into the C point is on the ground. So what is the height from the ground? 0, right? So we will put the value of height 0 here plus half m. Oh, m is 1 kg. V square. How we can calculate the V square? If you remember, I have shown you repeatedly how to calculate V square in such case. We will apply that formula. Which one? That equation. V square equal to U square plus 2AS. Now V square is what we are trying to calculate. So let it be as it is. The initial velocity is 0, so 0 square plus 2 into, for a falling body, acceleration will be acceleration through gravity, and s is the covered distance. Previously it was here, now the body is here. So what is the distance it has covered? 2 meters. So we will put it as 2. So v square will be equal to 2 to the 4, 4g. Okay, 4g actually we can replace the value of g also, that is 9.8. So 4 into 9.8, how much it is? Can you tell me? Calculate it and let me know. I guess it will be 39.2. Kindly check and let me know, okay? Acha. So if I replace the value of b square from there, 39.2. Okay. So this one, as it is multiplied by 0, the whole thing will become 0 plus 39.2 divided by 2. It will definitely be 19.6. Okay. So the answer is here. It will be 19.6 joule. So we can see that the total energy at point A and the total energy at point C, they equal each other, right? So as a result, what we can say, the stem follows the conservation law of energy. Did you understand what I tried to explain?
No, sir, I understand.
Hmm?
Understood.
Okay. Fatima, what about you?
স্যার আজকে খেললে আমরা দুইজন আর কেউ নাই
ওরা জানি না কেন জয়েন করতেছে না, পরে তো ঠিকই জয়েন করে, একটু দেরিতে জয়েন করে আর কি ওরা। ওকে,
Yes, understood.
okay. So now let us go to the next one, that is 7CD. Now, আচ্ছা, টাইমটা কি তোমাদের জন্য বেশি আর্লি হয়ে যায় 9:30?
না স্যার, ঠিকই তো আছে।
তোমরা এখনো ঘুমাইতেছিলা?
কি আমরা ঘুমাচ্ছিলাম?
হুম,
না
কয়টা
স্যার,
থেকে?
সকালবেলায় উঠি কয়টার দিকে, ফজরের নামাজ টামাজ পড়ে বাইরে একটু হাঁটতে যাই আম্মুর সাথে, হাইটে আইসে পরে
রুটিন ঠিক আছে, গুড। এরকম হলে দেখবা সবসময় ফ্রেশ লাগবে, মন খুশি খুশি থাকে। যারা সকাল লেটে ঘুম থেকে উঠে তাদের সারাদিন কেমন যেন ডিপ্রেস লাগে, আমি দেখছি।
ওই স্যার ফার্স্টে যেদিনকার উঠতাম সেদিনকার আল্লাহ কি ঘুম আসতো, পরে আস্তে আস্তে উঠতে উঠতে ঠিক হয়ে গেছে।
আলহামদুলিল্লাহ। 7 number C. A motor of 15 kilowatt. I already told you, whenever it will be said in the revision class, if you remember, it is said that the motor of 2 kilowatt or 15 kilowatt, it is the input power that is given. That means if you want to run it or use it, you need to give it 15 kilowatt power as input, then it will run. So input power is given. 15 kilowatt. You need to convert it to watt, so you have to multiply by 1000. Okay, fine. Can lift 2 quintal water. 2 quintal, I guess 1 quintal is equal to 100 kg, right? Let me check. 1 quintal is equal to 100 kg, right? So mass is equal to 2 quintal means 2 into 100 kg. Remember, and whenever there is ton, 1 ton is equal to 1000 kg. Okay, you must remember this. Okay, then what we have, in 1 minute, time is given as 1 minute, that is 60 seconds, to a height of 300 meter. Height is 300 meter. So what they have told to calculate, what is the effective power of the motor? Effective power means the output power. Okay, how can you find it out? Power. The equation to calculate power is work divided by time. So here, what work I am doing? I am lifting something. So whenever I am lifting something, I need to calculate the work done by potential energy, right? So what is the equation to calculate potential energy? Here you will notice that the force and displacement, these are not given. Okay, so we need to use this equation. Divided by t. Now, what is the mass of the object that I'm lifting? The mass is 200 kg. So 200 into g is 9.8, and what is the height? Height is 300 meter. So it will be 300 divided by the time. What is the time? 1 minute, that is 60 seconds. Okay, so this will be 5. 5 into 200 is 1000. So it will be 9800 watt. Okay, so this is the effective power. Understood?
Yes, sir.
Okay, now they have told us to calculate what will be the change in energy spent by the motor if the efficiency is increased by 5%. Acha, normally what I would like to suggest you, that avoid this type of efficiency changing problem. Okay, because better I have a better plan. Okay, so do one thing, you will be facing more of this problem in future. Means in the second 10 question or later questions, you will face this type of problem. Okay, so when we are done with the discussing all other creatives, we will discuss about this type of problem together. Okay, because I want to take a single class fully on this type of question, because these are a little bit tricky and a little bit difficult. Okay, you need to understand this. So I want to take a separate class on this. So when you are done with all the creative, and we will list up the number of creative in which this type of efficiency change problems are there, we will discuss them all together. Okay, so in one class it will be done. inshallah. So please remember that we will discuss 7D, this type of problem all together in a single class, inshallah. Okay. Acha. Then we have 8C and 10C. Acha. Kinetic energy is a kind of mechanical energy. We know the mass of Rohim is 30 kg and Korim is 20 kg. Rohim runs with velocity 5 meter per second, Korim with velocity 6 meter per second. As they are moving, as they are in motion, they have a velocity, so they have kinetic energy. Remember, Rohim runs with total work done by them to get this velocity is kinetic energy. Yes. Work done is equal to kinetic energy here because the energy is kinetic energy, not potential energy. They are not being lifted to some height. They are becoming in motion. Acha, either C as a either C. Whose kinetic energy was less calculated? Kinetic energy can be calculated by the equation half mv square, right? So we need to check whether the mass and velocity of both of them are given or not. Mass and velocity. So mass of Rohim is 30 kg and mass of Kolim is 20 kg. Rohim runs with velocity 5 meter per second. 5 meter per second. Everything is given. Kolim's velocity is 6 meter per second. Nazmul, everything is given here. All you need to do is just put the value. Okay. So kinetic
Okay, sir.
Ek is equal to half mv square, right? For Rohim, so I am using the subscript r, mr square, and here it will be half mk vk square. So half into mass of Rohim is 30 into 5 square. So it will be 15 into 25. Do the calculation and let me know what is the answer, okay? And here it will be half into 20 into 6 square. So it will be 10 into 36, so 360. Okay, so this will be the way. Easy, right? Mass and velocity given, all you just need to do is put the value. But here we are not done yet, okay? Because they told us to calculate whose potential energy is less. So we need to make a comparison between them. Calculate what is 15 into 250 is, okay? Then just write the value here and check which one is more, which one is less. I can actually see it from here, and I can see this is 375. 375 joule. This is 360 joule. So we will say that kinetic energy of Korim is less than the kinetic energy of Rohim. Clear? Now we will discuss about number 10. Number 10. Number 10C. How long will the body take to reach at C from A? That means we are being told to calculate the time, how long it will take. What is the amount of time? T. So let us see how we can do this. Okay. So 10C, we have to calculate the time, but what are the information given? The body has to come from which point to which point? From A to C. So A to C, what is the distance? 78.4 meter. The distance S is equal to 78.4 meter. Okay. So the initial velocity, always we know that it is 0 for a falling body. Okay, when a body is falling down, the initial velocity is considered to be 0. And G, we know that the acceleration will be acceleration due to gravity. Okay, so these are the information given. We need to calculate time t. Let us see which equation can be used. V equal to u plus at, then s equal to u plus v divided 2 into t, s equal to ut plus half a t square. I think we have already got, right? V square will be equal to u square plus 2as. This one cancelled at the beginning because this does not involve time. So for the first one, we need the final velocity, which is not available. Here also we need the final velocity, not available. So these two cancel. Now let us take a look at this one. S, U, and A. We need these three. S, U, and A is acceleration, which is G in our case, right? So we got. We will apply this equation. S is equal to 78.4 is equal to ut. Initial velocity is 0. So u into t will be 0 into t, half into acceleration, that is 9.8. It will be gt square, right? So 9.8 into t square. So 78.4 is equal to 4.9 t square. T square will be equal to 78.4 divided by 4.9. So do the calculation and find out the value of t. Okay, I can see that the answer is 4 seconds. Okay, Fatima, do you have any doubt?
No, sir.
Okay, good. Arafat, you joined too early for the next session. আচ্ছা, ওকে। সো আরফাত এই ভিডিওটা দেখে যদি ডাউট থাকে ক্লিয়ার করে নিও, আর এগুলোর বাইরেও যদি তোমার কোনো প্রবলেম থাকে তাহলে সেগুলো আমাকে পার্সোনালি মেসেজ করি, ওকে? আমি ডিসকাস করব। আমরা এখন যেটা করছি সেটা হচ্ছে ওয়ার্ক পাওয়ার এনার্জির প্রথম 10টা ক্রিয়েটিভের উপরে আমরা ডিসকাস করছি, ওকে? যেসব ডাউট নাজমুল আর ফাতেমা আমাকে বলছেন। তোমার যদি এগুলো ডাউট থাকে তো এই ভিডিওতেই ক্লিয়ার করে নিবা, আর যদি এগুলোর বাইরে কোনো ডাউট থাকে আমাকে মেসেজ করলে আমি সেগুলো পরে ডিসকাস করব ইনশাআল্লাহ, ওকে? আর এখন আমি আরেকটা ক্লাস তোমাদের সেটা হচ্ছে এর উপরে, কিসের? এই রেকারিং নাম্বারের উপরে, ঠিক আছে? রেকারিং নাম্বারকে কিভাবে যে, আচ্ছা এটা পরের ভিডিওতে করি। সো এটা শেষ করে আমি আরেকটা ভিডিও দিচ্ছি, তোমরা প্লিজ একটু সাথে সাথে আবার জয়েন করো, ডু নট বি লেট।